Hello, good morning. Am I audible? Okay. So today we are going to solve numerical, where we will do the MSc calculations of a classifier. Share the screen. So in the last lecture we discussed that there are various types of classifiers, and those are the classification problem or regression problem, or there may be some RNN system. So here we are going to discuss about regression problem. So here is the model. This is trained model. Already it is trained with some data. And the data was of this kind. X, here X is real number and Y is also real number. Okay. So when Y is real number, it is called as regression problem. When Y is discrete, it is called as classification problem. So with this data, this model is already trained. Now, at the time of testing, when the test inputs are given, this model gives some output. Okay. I will call it as X dash and corresponding predicted output Y dash. Okay. And those are like this. So the following data sets 1 and 2, they are like this. Find the total error as well as mean square error. Interpret the result. This is the numerical. And data set 1, in this, the predicted outputs are 9, 14, 12, 10, 15. So here they are 9, 14, 12, 10, 15. This is predicted by this model. But actually, they were 10, 13, 14, 9, 17. 10, 13, 14. Data set 1. So ideally, this model should predict these values. But what model predicts is these values. So we have to analyze this model, that how it predicts and how good it is. Okay. And this is a regression problem. This is a regression problem. Why regression? Because this output Y is a real number. It is a real number. It is not a discrete number or discrete string. It is a real number. So that's why it is a regression problem. So I'll wait for 2 minutes. All of you please arrange the writing materials. Okay. And then we will start solving this numerical. Okay. So write down this following statement. For the following data sets 1 and 2, find the total error as well as mean square error. Interpret the results. Then write down these two dataset values. Dataset 1, actually these are the values to be predicted, and these are the one predicted by this trained model. So write down these values for dataset 1 as well as for dataset 2. Write down these values. Okay, so we have to solve one by one. For data set 1, we will solve it first, and then for data set 2, and then we will interpret the results. So for data set 1, make this table actual values, predicted values, then error is equal to actual minus predicted. So actual minus predicted, 10 minus 9 is 1, 13 minus 14 minus 1, 14 minus 12, 2, 9 minus 10 minus 1, 17 minus 15, 2. So write down these values, these are errors. So error is equal to actual minus predicted. And then make square of error. So 1 square 1 minus 1 square 1, 2 square 4 minus 1 square 1, 2 square 4. And then make the sum of error and sum of square of error. Write down this table quickly. Done. Next is find the total error. So total error is mod of error. So how to write this total error? So mod of error, mod of 1 is 1, mod of minus 1 is 1, mod of 2 is 2, mod of minus 1 is 1, mod of 2 is 2. Sum it up. So total error is equal to 7. Write this down. Next is find mean square error. So that is sum of square of error divided by number of samples. So sum of square of error is 11. We have calculated this. Divided by number of samples. How many samples are there? 1, 2, 3, 4, 5. 5 samples are there. So 11 divided by 5. Answer is 2.2. So this is solution for data set 1. For data set 2, repeat the same process. Try to find out the error, square of error, total error, mean square error. Then we will discuss the solution. Here are the values for data set 2. All of you please solve it quickly. Okay, so let us compare the answers for data set 2. So these are the actual values. These are the predicted values. Error is equal to actual minus predicted, 10 minus 10 0, 13 minus 9 4, 14 minus 14 0, 9 minus 9 0, 17 minus 20 minus 3. So if we sum it up without taking mod, it is 1. The sum is 1. The square of error, 0 square 0, 4 square 16, 0 square 0, 0 square 0, minus 3 square 9. So if we sum it up, it is 25. It is sum of square of error. Then we find the total error is equal to absolute value of error. So we have to take mod of each of these values. So for minus 3, mod will be 3. Rest of the values are as it is. And the sum is 7. Then mean square error is equal to sum of square of error divided by number of samples. Number of samples are same, is 5. Sum of square of error is 25. So 25 by 5 answer is. Now what is the interpretation? Interpretation is if errors are huge, MAC is high. If errors are huge, MAC is high. Also, square is taken in MAC because square function's first derivative has only one minima. So here we took the square, why not cube, why not fourth degree? Because the derivative of this square of error has only one minima. So that's why it is the correct measure to find the error. Okay. So here the mean square error for data set 2 is 5. Mean square error for data set 1 is 2.2. So we see if we observe this, here we have the huge error like this error of 3, this error of 4, this error of 4. Although other samples are matching, so there is error of 4 and there is error of 3. Whereas in this error of 1, error of 1, error of 2, error of 1, error of 2. So that's why if the errors are huge, like this 4, this is 3, then the MAC is high. So that's why this is a perfect measure to find how the trained model is performing on a test data set. Any doubt, any query? All of you please write down this interpretation. So when we perform the classification, there are four different types of interpretations, like true positive, true negative, false positive, false negative. In last lecture, we discussed about if it is a cat identification problem, and if the model says plus, means cat is there, and actually cat is present, then it is true positive. Then model says cat is not present, and actually cat is not present, then it is true negative. When cat is present, but model says negative, then this is false negative. If model says cat is present, but the cat is not present, then this is false positive, like this. So these measures we discussed: precision, recall, accuracy. We solved a numerical to calculate these based on the confusion matrix. Then what is training data? What is test data? So training data is used to learn a model. So when there is some data set, what we do is we partition the data sets. Some rows are treated as training data, and remaining rows are treated as testing data. So the data used to learn model is trained data or training data, and remaining rows we can use to assess the accuracy of model, that is test data. Then there is a concept of overfitting. So overfitting means what? The trained model gives very good accuracy for training rows, like training data. So for these rows, it gives very good accuracy. For test data, it is not performing that good. So here you can see. So over here on y-axis we have accuracy, on x-axis we have epochs, and we can see that for trained data, which is in red color, the accuracy is quite high. As the number of epochs progresses, the accuracy is quite high. But when same number of epochs are there for test data, which is indicated in blue line, the accuracy is low. So this scenario is known as overfitting. So model performs well on training data, but poorly on test data. This is known as overfitting. Then there are these concepts of bias and variance. So bias means expected difference between model's prediction and truth. So actual value and predicted value. So what is the expected difference between them? That is bias. And variance means how much the model differs among training sets. So if I use the different subset of a original data set, how it varies. So based on these things, if there is high bias, then the model makes inaccurate predictions on training data. If the model has high bias, the model makes inaccurate predictions on training data. On training data itself, it is not performing well. Then low bias means model makes accurate predictions on training data. So model has low bias means, yeah, it is performing well on training data. Then high variance means model does not generalize to new data sets. So if the model has high variance, if there is some testing data for that data set or for those samples, the model is not performing well. Then low variance, in this case, the model generalizes to new data set. So for test rows or for new samples, the model really performs well. So this is low variance. Then which are the different supervised learning algorithms? So some of them are linear regression, then decision trees, support vector machines, k nearest neighbor classifier, and then neural networks. Then these are the some of the popular tools used for performing the supervised learning. So scikit-learn is most popular tool. It is used for classification, regression, and clustering, and it uses Python as a programming language. It is most popular. Next is Spark MLlib. So here we can perform classification, regression, clustering, but for those people who are more comfortable with Java programming or languages like Scala and R, they can use this particular tool. Then Pika, this is age-old tool. It is more towards a GUI-based classification, where they have some customized GUIs. You have to load the data set and then you can perform the machine learning. So this is quite easy. And the language that is used in background Java, but here the disadvantage is you cannot customize or you cannot make much changes because it is GUI based, so we don't have access to the code. So if you want to change a few things, there are some limitations. It can perform these operations like classification, regression, and clustering. Then there are few frameworks like Cafe and TensorFlow. Out of these, the TensorFlow is very popular. It is released by Google, and they are using this for various image recognition tasks as well as speech recognition tasks. And in the background, they have neural networks, and the languages are C++ and Python for Cafe and Python for Tensor. And what is classification? So in machine learning, classification solves the problem of identifying the category to which a new data point belongs. For an example, say there is some model like this, and initially we are performing the training. So we are performing the training. At the time of training, what we provide? Data as well as label. So this is data and this corresponding label. Now observe here, this is X, this is Y. So in X we have 1, comma, and Y is E. 1, comma 2, Y is 3, comma 6, Y is B. 9, Y is 3. Here A. Okay, so this data along with labels, this entire thing is provided to this model. Okay, just observe carefully. These are the data points. How many samples are there? 1, 2, 3, 4, 5 samples are there. 5 rows are there. So 5 samples are there. And how many classes? Just observe this Y column. How many unique classes are there? Only 2 unique classes are there, A and B. So there are 2. And when we provide this data to this model is trained. So once this is trained, we don't provide this X and Y because it is trained already. Now this time we provide X cap and Y cap. So we don't provide Y cap. We expect the Y cap from the model. So we provide X cap. Say X cap is 1, 1.5. 1, 1.5. So if this is the input, 1.5. If this is the input that is given to the model which is already trained, so this unknown sample or test sample, X cap or X hat, and here if this is given to this model, then what this model should predict? What this model should predict? A or B. So by observing this, you can tell that it should predict A, because this sample 1 and 1.5 is near to the samples of A, than B. So B are 5, 6, 7, 9, they are higher values, and A are some lower values which are near to 1. So 1, 1.5, definitely this will be class A. So this is called as classification. The model was trained using some rows. How many rows are there? 1, 2, 3, 4, 5. So 5 samples are there in this trained data set. And then for the at the time of testing, we have this sample, and for this sample we ask that what is the label. Okay, we ask that what is the label for this, and this is the predicted label. Then say Y cap is actual label. If this is A and Y dash, this is Y dash predicted label. So y dash is predicted label. This is also A. Then what we say, the classifier is good, the model is good, because actually the label was A and it is predicting A, so that is correct. But say if it is B and if it is A, actually it was B, but what the model predicts is A, then this is wrong, or vice versa, like A, B, then this is wrong, like that. Okay, so this is a classification problem, and what we expect is the model should predict the correct label for unknown sample. Why I am saying unknown? Because 1, 1.5, this is not present in this data set. This sample is not present in this data set, and then for this, the correct label is expected. Any doubt, any query? Any doubt, any query? Okay, so let us proceed. So here in machine learning, I'll read this again. In machine learning, classification solves the problem of identifying the category to which new data point belongs. So this was the new data point. To which category means to which class it belongs. Okay. We build the classification model based on the training data set. So this is training data set containing data points and the corresponding labels. So these are the data points which are mentioned within square bracket, and these are the labels. For example, let us say that we want to check whether the given image contains a person's face or not. Okay, so this is another problem. Face is there or not. So two classes. Face is present or face is absent. So we would build a training data set containing classes corresponding to these two classes. Okay, so we provide the data. We provide the data, and here the label will be face, non-face, like that, either face or non-face. We then train the model based on the training samples we have, and train model is then used for inference. Inference means testing. Then overfitting, same concept is explained over here. We need to provide a sufficiently large number of samples. So in this example, how many samples are there? 5 samples are there. 1, 2, 3, 4, 5. 5 pairs of X and Y. We should have sufficiently large number of samples, means large number of rows. Otherwise, the model will perform well on trained data, but it will perform bad on test data. If there is insufficient number of samples, then the algorithm will overfit to the training data. So if there is insufficient number of samples, it is a problem. This means that it won't perform well on unknown data because it fine-tuned the model too much to fit into the patterns observed in training data. So it's a big problem. So that's why we should have sufficient data. This is actually a very common problem that occurs in the world of machine learning. It's good to consider this factor when you build various machine learning models. So what you have to look for? You have to look for sufficient number of samples in training data. Pre-processing the data. So we deal with a lot of raw data in the real world. So when we acquire the data at the time, the noise may be present. Few operators are there. They don't make the entry of the data. Okay, and they provide the data set like that, and we have to process that data set. Sometimes wrong entries are there, or like outliers are there. For example, there is a status yes or no, and some data operator may enter okay. So the status expected values are yes or no, but the operator has entered okay. So what is to be done with such a data points? So we have to pre-process the data. Machine learning algorithms expect data to be formatted in a certain way before we start the training process. In order to prepare the data for ingestion by machine learning algorithms, we have to pre-process it and convert it into the right format. So what are the different pre-processing algorithms and how to process the data using scikit-learn and other libraries? We are going to discuss about them in the next lecture. So in the next lecture, be ready with Google Colab notebooks. So parallelly, we will try to execute the code and we will discuss other things. Okay. So any doubt up to this point? Any doubt? Any query? Okay. So with this, I'll stop here. I'll download the attendance list. Thank you for attending the lecture. Bye bye.